Hello everyone, my name is Aarohi and welcome to my channel. So guys, in this video I'll show you how to implement object detection using YOLO-R. So YOLO-R stands for you only learn one representation. So YOLO-R is a new object detection algorithm and it got released last year in 2021. So guys, YOLO-R is written in TensorFlow and in PyTorch, right? So today I'll show you how to implement YOLO-R using PyTorch environment, okay? And YOLO-R has different model variants like YOLO-R P6, which is a small model. Then we have YOLO-R W6, which is a medium model, and YOLO-R D6 is a large model, and then we have YOLO-R E6, which is a extra large model. So in my today's class I'll show you how to implement YOLO-R P6, which is a small model, okay? So let's begin. So guys, whenever you want to try something new, I always recommend you to create a separate environment and then work in it. So let me show you. I'll help you step by step to set up the environment. Just open the Anaconda prompt. So this is my Anaconda prompt, right? And guys, this is my D drive. Okay, let's enter in D drive. Under my D drive I have created one folder with the name of YOLO-R_env. So this is the folder. In this folder I have created the separate environment. I have all my code which is related to YOLO-R in this folder only, right? So you can also create a separate folder and then you can work under it. Now let me just enter in this folder cd YOLO-R_env. okay, so this is a folder. Over here I have created a separate environment. So how we create environment? We just write conda create name YOLO-R. So this is the environment name I am using, right? Conda create name, and over here you can give any name. So I already have created the environment with this name, so I'm not running this command again, okay? After that, once you create the environment, second thing is to activate the environment. So conda activate YOLO-R. So I have activated the environment now. So once you activated the environment, the next thing is to install the PyTorch version. Why we want PyTorch? Because today we are going to run this YOLO-R algorithm using PyTorch. So you need a PyTorch version installed on your this separate Anaconda environment. So guys, here you have to take care that you need to select the PyTorch version as per your GPU or as per your CPU, right? So the command which I am using to install the PyTorch is this, right? So I'm using Torch version 1.8.1 with CUDA 11.1, and I'm using Torch Vision this and Torch Audio this, okay? So now I am using GPU 3090 RTX 3090. So with that these versions work well. So these are the compatible versions. So I'm using this Torch version. So as per your resources, you have to install the correct Torch Vision and Torch Audio versions, okay? So once you install the Torch, next thing is to install Cython. Pip install Cython. This is what you need to install. So I have already installed it, so I'm not running this command again. So but you can install Cython like this. So once you install Cython, next thing is to install PyCoco tool. Okay, so the command for that is PyCoco tool. Just a second. So okay, this is the command. I am just stopping this command because I have already done the code. So this is the command which I'm using to install the PyCoco tool, okay? So once you done these three steps, install Torch, Cython and PyCoco tool, now we'll go to the browser and you have to clone this YOLO-R repo of this person, okay? So we are cloning this GitHub repo and then we will do some changes. We'll modify some lines over here, some files in this repo, and then we'll build our own custom object detector, okay? So clone this. Once you clone this, you have to, so remember this YOLO-R env folder, in this I'm working. So this is the, like this you'll get folder like this. Okay, once you clone this repo, you'll get a zip file, unzip it, you'll get file like this. So I've just rename it, and this is my code, right? So now I have my whole code in this directory, right? And guys, the object detector which I'm making today is a traffic sign detection algorithm. Oh, okay, it will detect different traffic signs. I'll let you know about the dataset in some time. So but let's finish this installation part first. Okay, so clone the GitHub repo, and then I have renamed that repo to this. Now you have all the files and folders under this folder. Okay, after that what you need to do is, next thing is our dataset. Now you can see this is the dataset folder. This folder you will not get one when you clone the GitHub repo. This folder was not included in that. This is the your dataset custom dataset folder. Put your dataset folder over here, and when you will open this dataset folder, I have a folder with the name of original dataset, and when you will open it, you will see images and their corresponding text file, right? So the dataset, if you want to annotate your dataset, so guys, YOLO-R accepts the data in the same format which YOLO v4 or YOLO v5 accepts. Okay, same format means for every image you need one text file. That text file will have the annotation detail of that particular image. So that means if you have 100 images, that means you need 100 different text files. Okay, so this is my data set. I have 1482 records in it. Okay, so that means, okay, so that means let me tell you about the data set. So I have 741 images, and I have 741 annotation text files, corresponding text files. And this dataset have 4 traffic signs. So one is speed limit, right? Speed limit means 20, 30, 40, 50, 60, like different speed limits. Okay, one class is speed limit, second class is yield, and third class is mandatory. This mandatory class have traffic signs like go left or go straight, go left or straight, keep right, keep left, roundabout. These kinds of traffic signs comes under mandatory class. And then we have fourth class, other. In this other class we have traffic signs like no entry, stop, give way, these kind of signs, right? So how many classes we have? 4 classes: speed limit, yield, mandatory, and others. Okay, so I have shown you my dataset and the corresponding text files also. You have to place your dataset folder over here. This is your cloned repo. Over here you have to place this dataset folder. Okay, now once you done that, now the next thing is divide your dataset into a train test split. So how we do that, guys? Process.py file. So guys, this file, again this file you will not get in this cloned repo. I have placed this code myself. I will share this in my GitHub repo. You can take this code from there. Let me open this process.py file. So here you can see this is the path of my dataset folder, right, where my images and text files are there. Now what I want is, I want to create 2 text file, one file with the name of train.txt and other file with the name of test.txt. In train.txt I want to store the path of the images which I want to use to train my YOLO-R algorithm, and test.txt file will have the path of those images on which I want to perform the testing. Okay, and then once you execute this code, how you will execute this code? Just do, okay, just enter in the folder first. Sorry. So just enter in the folder. This is a folder, right? YOLO custom dataset traffic. Now run python process.py. Once you execute this command, you will have, go to your dataset folder, you will have train and train and test.txt files over here, and when you open these files, just see these are the records we have in train, right? So these are the different images we are using for training our algorithm, and if you open your test.txt file, these are the different images we are using to test our algorithm, right? So this process.py code, I'll give you that. Now after that, what you need to do is, yes, now okay, now open this data folder. Okay, data folder. When you will open this data folder, you will see this custom.yaml and this custom.names. This I have created. When you clone the GitHub repo, you will not get these two files. These two files I have created myself for our custom dataset, because we want to work on custom dataset. That means you need to create these two files yourself. Okay, so now let me open these two files and show you what is there. So custom.yaml file have these details. So what we have here, so in this train folder I'm giving the path of train.txt, because train.txt is holding the detail, means using that data will train our algorithm, right? And in val folder we'll give the path of that test.txt file. Okay, and then how many classes you have in your dataset? So we have 4 classes, right? Speed limit, yield, mandatory, and others. Okay, so that's why I've written 4 over here, and over here you need to write the name of those 4 classes. And guys, if you're working on your custom dataset, then you have to make changes over here. Okay, so this is what we have in custom.yaml. Then we have custom.names. Under custom.names you need to write the name of the classes, and one class name should be in one line and other class name should be in next line. This is how you need to do. So these are the 2 changes you need to do. Okay, what we did, under data folder create custom.names and custom.yaml. Okay, now next step is, okay, yes, so now just go to the CFG folder, configuration folder. Here this file YOLO-R p6_custom, this is the file which I have created. When you clone this GitHub repo, you will not get this file. What I have done is just copy this YOLO-R p6, right? Once you, basically what I have done is I have made a copy of this file and then I have renamed it to this, and I have made few changes in it. Okay, so this, now let me open this file. When you will open this file, okay, and let's go up, yeah, so batch size is 64, subdivisions are this, height and width of the images are 1280, number of channels are this, right guys? What you need to do over here, just do Control F and search classes. When you will search classes, here I have written 4, right? But when you will clone, when you will copy that this configuration file, you will get 80 over here, because this file is prepared on Cocoa dataset, and Cocoa dataset have 80 classes. Okay, so you have to change it. Search classes, when you will get the classes, search the classes and replace it with 4, because we have 4 number of classes in a dataset, and then find next. You will see another classes, change that also. You will get classes 4 times. Change the classes, number of classes in all those 4 times. Okay, and just see above this, above the classes, above this YOLO, over here number of filters. So we are using 27 over here, but you will be having initially, when you will use that configuration file, you will have 255 over here. So you have to change it to 27. Okay, so why we are doing it 27? Because how we get to know like 27 is the number over here. So classes plus 5. So how many classes we have? 4 plus 5 is 7 into 3 is equal to 27. So this is how we do it. Okay, so change the number of filters over here. So you have classes 4 times, right? So you have, when you will search in this file, you will get classes 4 times. Change the values for all the classes, and just above classes is here, and just above filters, change the number of filters over here. Okay guys, just remember one thing, you have to change the filters which are just above the classes. That's it. That means you will change the filters 4 times only. Okay, so once you done that, then we have another change, and that is, just a second. Okay, okay guys, give me a minute, I'll let you know. We have to do few more changes in this file, so just a minute. 206 So just go to line number 1567. 1567, yes, here. From here to here, 207, 208, 209 and 2010. You have to change the number of filters here also. Remember, don't change any other filters. You have to change the filter value, 4 filter values over here, and then you have to change the filter values which are above those 4 classes. That's it. These are the changes you have to make. Now this is a configuration file which we are using in YOLO-R for our custom dataset. So after that, once you done that, now we will train our algorithm. So how we train our algorithm? Just go here and paste this command. Just a second, let me, yeah. So this is the command, python train.py. So batch size 8. So guys, if you face memory issue, you can write batch size 8, or otherwise you can increase the number of batches. Okay, and then we have image size is this, data custom.yaml. Remember, we have prepared under this data folder, we have prepared this custom.yaml file, right? This file is containing the information about our dataset, train.txt, test.txt, number of classes and name of classes. We are defining that. Okay, and then we are using, okay, just a second, cfg. We have created our configuration file, YOLO-R P6 custom.cfg file. Okay, so we are giving that file, and then device 0 and epochs, how many epochs you want to run. So this command will train your algorithm. Okay, so once you done the training, now let me show what you will get. Okay, just go back to your dataset folder. Here you will get one folder with the name of runs. This folder, when you clone this GitHub repo, you will not get this folder. This folder will get created when you will start the training process, and when you will open it, you will get another folder with the name of train, because we are training, and under that you will get folder. When you will open this folder, here you will see the results. Now you will get one weights folder. This weights folder is having the trained weights. So I have trained my algorithm for 50 epochs, right? So I have those weights over here. You will have last weight and the best weight, last weight and best weight. Okay, so now we will use the this particular weight file and we'll test our algorithm. But before that, let me show you some results also. So you can see this is our result. These are the different reports, and you can see these are the some predictions on our test data, right? And you can see here also these are the different predictions we are getting. Right now let's test our algorithm. Now how we test our algorithm? So for that you use this command. Okay, so where is that command? Just give me a second, please. Yes, so this is the command, python detect.py. Now you have to, under source, you have to give the path of the image on which you want to perform the testing. So under inference folder, we have images folder. Under that images folder, I have one image with the name of e.jpg. I want to perform the detection on this image. Okay, and configuration file, we are giving the path of our custom configuration file, right? The custom configuration file which we have prepared. And weights, so guys see, run train exp6 weights, remember, see here, run train exp6 weights, and from this weights we are getting the best weights. Okay, and I'm writing the confidence over here, like this is the minimum confidence we are looking for. Image size is this, device is this, and data custom dot names, we are providing the name of our classes, right? Custom dot names. When you will execute it, you will get output. Okay, it's getting executed, yes. So results is saved in under inference folder, we have output folder, over there you will get your results. So now let's go back, this is my inference folder. Under inference folder we have output folder, under output folder we have this image, and when you will see it is detecting that yield traffic sign. So guys, this is how YOLO-R work, and I'll share the GitHub repo. I have mentioned the link in description section. You can get that code from there. And guys, if this video is helpful, please like, share and subscribe my channel. Thank you for watching.